Hi, in this presentation we will study knowledge representation. We will identify some common structures that we're going to use to store knowledge. During the period of time in which expert systems were a very popular area of research in artificial intelligence, we used to have what we will call knowledge engineers. Knowledge engineers were in charge of mapping knowledge mainly from human experts like medical doctors, lawyers, some humans that have some type of expertise, and the mapping first identifying some of the knowledge that needs to be mapped into a specific set of structures. One of those examples of structures that were used before is the one that we call semantic network. Think about maybe, I don't know, having a biology, to make this example easy, having like a biology textbook in which we want to map some of the information that is one of the pages into a structure that we can use later to manipulate the information that is there and make some inference or conclusions or predictions. So maybe in this page, they were mapping, or in this unit that were extracting information, they're talking about animals, birds, and then examples of birds like is there. And you can see there the idea of the semantic network is kind of like a graph in which the nodes are objects and then the edges are some relationships. Like for example, here you can see that a bird is also an animal. It's kind of like a subclass, and then it has some properties that can fly, that has wings. So this is kind of how is that you make that representation. I mean, how is that you do the mapping. Another common way that is basically very similar is the idea of a network representation. In the previous one, we were more concerned about the semantic, maintaining the meaning. So in this case, it's mainly about some type of properties that you maintain with the objects. Like here you see snow as a color and it's white. I mean, they are kind of similar. Now there will be different ways in which you can define your structures, and that's when we see different type of research. Like in this case, in the early 60s, we have ideas of representing other type of information into the graph. Like you see here, I mean, all those details about definition of a plant. This approach presented for this researcher in the early 60s also give us expansions in which, for example, concepts definitions can also find commonalities, like in this case, the intersection. So you can follow the graph and find some type of intersection. Look at the following specific representation of a sentence. In this case, the sentence that is Sarah fixed the chair with glue. Look at how we have all the components here, which is the agent, which is Sarah, and then the action fix. And then here we got kind of these attributes for the action, that is time, the object, the instrument. So in this case, look at that changes in time can also, I mean, we want to be working with this type of sentences. I mean, Sarah fixed the chair, so that was in the past. Sarah will fix the chair, so that will be an easy change into the structure. I mean, and then look at that. If we, I mean, this give us the possibility of also understanding. I mean, we want to store information on what is the meaning of past, what is the meaning of future. I mean, we can put something like future. It didn't happen yet. That action. I mean, there is a lot of ways that we can have this to be useful. Now, there will be the part of conceptual dependency, which I want you to look into. In one of the activities, I'm going to ask you to look into some of the concepts that are in this slide associated with some of the dependencies here, and on that will lead us into the examples that are in this slide that you can see the sentences that are here on the third column, how this can be represented on in the middle. So here there are some of the conceptual dependency components of the graph, and on the to the right you can see an example when to implement that. So just starting with number one, which is an easy one. Like for example, we got an John run, and then how is that we have that representation in that way. And remember that there is you're going back to the other slide, you can see more about the definition of each one of those concepts. So look at all the details that we have here for the sentence John ate the egg, and for the other sentence that says John prevented Mary from giving a book to Bill. And how is that we got all this information represented in this graph. So what you need to understand is that we're doing the mapping of that specific sentence into that type of structure. Now, another interesting concept is that there is based in scenarios that says, well, if you are going to a restaurant, there will be very predictable type of scenarios there. Like for example, when you are enter, we can kind of predict what can be the type of conversation or the type of exchange of sentences that can happen during that time. The same, what is it that we can have during the ordering, and you can see that this idea can help us into kind of design an automated system, for example, for somebody that is like that we see nowadays for ordering, or maybe having a small conversation with a robot that is going to be taking your order. But this is another way that we says, well, we, instead of going with the previous one that was kind of very complex in the detail, in the previous one that you saw, the conceptual um, the graphs that we just saw before, is kind of like learning another language and representing an English sentence into that set of graphs. So in this case, it's kind of like giving us the very little changes on what we had the script, right? Because it's just like a subset of all the previous approaches that we had there. Now, frames, for some people, they see in the section of frames kind of like a predecessor of object-oriented, because frames are going to be basically objects that have relationship maybe with other objects that has some type of attributes, properties, procedures associated with the frame. And the initial idea of a frame is that a frame will be representing like a kind of like a rectangle. So that's what they were using the term frame, because here we had like a kind of like, this is the frame for the object hotel room. And then it's a specialization in this case of a room. So it's kind of like saying belongs to a classroom. You see, this is before object oriented. This is and then we have here some attributes. We can have maybe some properties that are here, and then again we're representing in this kind. And again, the part that is interesting here is that we were talking at that time about designing a specific programming language, but the representation of knowledge. Now, for the rest of the presentation, I just want you to go and look into some of the examples, and we will practice basically the semantic nets and frames for representing some knowledge for this lesson. But I still want you to go and look in other examples that the people has proposed for representing knowledge.